welcome back everyone. In this lesson we'll look at sets and dictionaries, which are the backbone of many Python applications. We now move away from the sequence umbrella that focus more on ordered, indexable data structures and move towards the containers family. These are usually structures that still hold multiple elements but do not necessarily maintain order or support indexing. Let's kick off with the lesson, shall we? A set is an unordered collection of distinct hashable objects. Being unordered means they do not have a specific order and thus cannot be accessed by index, like lists, for example. But what does it mean to be hashable? Well, it means that the object has a hash value that never changes while the program is running. Think of hashing like a national insurance number. It uniquely identifies someone and once assigned is fixed. You may also ask, but why is hashing important? Well, it allows Python to perform values comparisons, such as checking for membership in a set, absurdly fast. While comparing elements in a list takes longer, the bigger the list gets, hashing allows Python to check if an object is in a set in a constant time, regardless of the set size. A little extra memory is needed for these hashes, but the speed boost is well worth it. To properly exemplify the usage of hashes, let's say Dave and Chris went to a pub to have a beer. As you may or may not be aware, it's never a single beer, and they ended up going on a degustation tour. However, we can consolidate or call the extensive beer repertoire by using the hash function, which returns us a random integer. This in turn allows Python to more quickly perform comparisons or other types of membership functions. Also, don't worry if your hash function returns a different value. The function contains a randomization for each time you start the program. This is done for security reasons. In certain scenarios, like in sets, Python uses hashing under the hood to check if two objects are indeed the same, thus including or excluding a new object from the current set. That's why the objects within the set must be hashable. Python hashes any new object and compares it against the hash of all existent objects within the same set. So, which objects in Python are hashable? Essentially, the built-in objects in Python that are immutable are by default hashable. This includes integer, floats, booleans, tuples, ranges, and strings. You can also create your own hashable objects, but that's out of the scope for this course. Now, if I compare both outputs, you can see that the result returns true. I hope that the concept of hashing makes slightly more sense now. Alright, let's get back to the set use case. Remember, set is an unordered collection of distinct hashable objects. We typically use sets when needing to store unique items, such as the items of a list without duplicates. Sets are created using comma-separate elements within braces. They are powerful because they let you perform mathematical operations like union, intersection, and difference. For example, if I now create a set B and I want to get the items that are in either set, which is called union, you use the vertical bar. In this case, we'll have the items from 1 to 6 without repeating. For cases in which we want the items that are present in both sets, which is called intersection, we use the ampersand character. Here, only the numbers 3 and 4 are present in both sets. And how would you get the items present only in set A? For this, you perform the difference using the hyphen character. Lastly, to get the items that are in either set, but not in both, we use the caret sign. This is known as the symmetric difference. Here we get the values at the ends 1, 2 and 5, 6. There are a lot more operations you can do with sets, but these should already cover plenty use cases. I'm appending a link in the description with all the set operations in case you are curious. We'll resume with dictionaries in the next lesson. I hope you enjoyed.